name is Kathryn Grayson Nanz. I'm a developer advocate for Kendo React and for design things at Progress. I am a UI designer and a front-end developer who especially loves to be on the front of the front end, which means that my dream day at work would be to spend the entire time writing nothing but CSS. The longer I have been doing this job, the more I have discovered that is an unpopular opinion. But today, I'm the one at the front of the room, so we're going to talk about CSS, especially responsive CSS. The way that we write CSS has, thankfully, quite frankly, changed quite a lot over the last decade, and even, honestly, in just the last few years. One of the most noticeable places where we see that change is the fall of the humble media query. Because in ye olden days of web development, if we wanted to create websites and applications that were mobile responsive, it meant that we needed to write a series of media queries that were based around very specific device breakpoints, and then we reworked our content to be optimized for each different size. And if you were coding then, you probably remember getting like 2 or 3 very different mock-ups from a design team for like web, for desktop, for tablet, maybe even for different sizes of phones. And yes, I know someone out there is going to say that the truly old days of web dev were table-based layouts, and I did those too, and they also sucked. So shout out to the email developers who are still very much doing that today. But in the world of web and application development, CSS frameworks stepped in, and they kind of eased the pain of the device breakpoint world. So we saw the rise of things like Bootstrap or Skeleton, things that defined different automatically resizing column-based layouts, because the task of writing all of those different media queries was a lot of work. Slowly, though, we've seen best practices around writing media queries shift by necessity from device-based breakpoints to content-based breakpoints, as more and more devices started coming out in all kinds of different shapes and sizes. It just became unsustainable to try and cater to individual devices, and it made more sense to shape our breakpoints around when the content needed to shift. Now, though, with screens available in pretty much any size and shape you can imagine, from like the one here on my wrist to the one up here, the era of breakpoints is over. We need to shift our approach again and start thinking about design as fluid. Fluid design means that rather than hitting any kind of a point and like snapping your content into a new layout, our content should always be kind of continually adjusting based on whatever space is available. So you're never going to feel that big snap as you're resizing the screen. You're never going to see components kind of jump all at once and reorient themselves. This is more of a subtle shift that's going to be happening kind of constantly, depending on how each individual element fits the space. Thankfully, the technology, again, has moved with us and come a long way to enable that. But a lot of us kind of got stuck. Right? We got really used to throwing in a media query or 5 or 10 or 20 in order to make things responsive. And maybe we never necessarily broke that habit. But now we have fantastic CSS features, things like grid and flexbox and calc and clamp and aspect ratio. And with all of that kind of stuff at our fingertips, it's time for us to ditch those media queries. So today, we're going to kind of start at the top and work our way down from big picture display formatting all the way to the smallest CSS units. And as for your old style sheets, don't worry, we can refactor. We have the technology. Let's start with 2 of the most popular kind of responsive display options, which is grid and flexbox. These have actually been around for a minute, with Grid hitting full browser support in 2017, Flexbox in 2013, but a lot of folks haven't really played with them, dived really deep in them, and don't necessarily understand the difference between them, when they should use one or the other, or possibly even both together in concert. Many people assume a kind of false equivalency between the two, and that can create this misguided either-or approach, feeling like you have to choose either Flexbox or Grid for a layout, when in reality, not only do these have very different use cases, but they can be used together to complement each other. We could realistically spend an entire session, and maybe 2 or 3, doing a deep dive into grid, which is amazingly powerful. But for our purposes, I really want to focus on how these work at a high level, how you can use them to handle layouts on your page in a way that will allow for natural wrapping and responsive adjustment, and without needing to include media queries. Grid is primarily focused on creating a grid, which is something with multiple rows and columns that you can then populate with elements. You do this by creating a container grid element, which you can then fill with child elements. And there's a huge number of customizations you can make in terms of grid rows, columns, cells, which allows you to create grid layouts as simple or complex as you could possibly imagine. But if our goal is creating simple, responsive layouts, let's take a look at some of the most relevant features. Grid comes with the ability to repeat columns or rows automatically, as well as auto-fit, which is going to automatically size columns into the available space. So, for example, in the code here, Grid is going to turn your content into columns which naturally fill the space you have, with each column having a minimum width of at least 300 pixels and a maximum width of no more than 1 FR, which is fraction. This allows us to set some kind of general guidelines without needing to necessarily use breakpoints in order to do so. That 1 fraction is a new CSS unit, or newer CSS unit, that stands for fraction, tells the browser to divide the space evenly, give each column 1 fraction of the space. So in this case, 3 equal columns, each take up 1/3 of the available space, never getting smaller than 300 pixels. We could add another div, we could take one away, the grid would automatically handle that calculation and adjust the display for us. And if the screen is too small to fit all of the columns kind of side by side, it'll automatically wrap the remaining columns down to the next row. Again, of course, barely scratching the surface here, but if you are looking to create a more complex layout with grid, these are some of my favorite resources. First, a complete guide to grid, which is a fantastic breakdown on all the different ways you can customize your grid, columns of varying widths, template areas, the gap between grid cells, so much more. But grid by example, I think, is actually the real winner here. It is one of my all-time favorite pieces of documentation, which is probably the nerdiest thing I've ever said. And it's a great jumping off point for creating a new grid structure. This was made by Rachel Andrew, and she's put together a series of good, kind of more complicated examples for different popular grid layouts. And anytime I'm going to create a grid that's more than like your standard 5x5, I start with one of those code samples as a launch point and kind of configure from there for my own purposes. Flexbox takes a similar but not quite the same approach in helping lay out elements on the page and adjusting automatically as needed. But rather than creating a full grid, which is rows and columns, Flexbox is about the positioning of child elements relative to a parent element. So if you need to work in 2 directions at once, horizontal and vertical, you want a grid. If you're just thinking about one of those, you're just doing vertical, or you're just doing horizontal, Flexbox is the way to be. Flexbox is also especially good for positioning elements within a parent element, including that much made fun of vertical centering, which is no longer a struggle in CSS. In fact, using Flexbox, you can vertically and horizontally center elements with just a couple lines of code, so I don't want to hear any more complaining about it. Branching off from this, you might consider combining Flexbox with Grid, which allows you to very easily position the elements within a grid cell using Flexbox. So they work and play really well together. You don't have to be afraid to mix and match, and you don't ever feel like you need to make a choice between them. But for now, let's bring it back and talk about how Flexbox handles responsiveness for you. And the main point of interest for this is the Flex Wrap property. Flex will start by attempting to fit everything that you've written into one row or column. But if that's not going to work, you can tell it to allow wrapping by setting Flex Wrap to wrap. If Flex Wrap is not specified, Flex is going to try and squish the elements to keep them all on the same line if no minimum width is specified for those child elements. Or if you have set a minimum width, it's going to allow them to kind of overlap outside of the parent container. It'll just kind of push them outside the boundaries. So with Grid and Flex, you really just have to decide whether you want your content to squish and fit all in one place, or whether when it overflows, you want it to wrap, and then set those properties accordingly. Both are really good tools to have in your toolbox for creating responsive user interfaces. And again, if you're looking for some resources, these are a couple of my favorites. Flexbox Froggy is just a fun game in general, but also it will teach you all of the different properties to the point where I can do Flexbox now without having to look up the syntax, because I just positioned those little frogs on lily pads for a long time. It really helps it to stick. If you don't have all of that memorized, though, Flex is a really good kind of visual cheat sheet for you to kind of look up all of the different properties as you're working. Once we have our general layout in place, it's time to start setting specific properties on our elements. And the good news is we don't need media queries here either. Container queries have been kind of a long time coming, and folks have been very excited about them. And the good news is that now they are supported in all major browsers. There were some browsers that had kind of implemented support for this in the end of 2021. Firefox added them last year, so as of 2022, they are now supported everywhere. I will be including them in this talk and in other talks, which, by the way, everything I mentioned here does have full cross-browser support. There is stuff coming that will be neat and fun, but I really like to focus on things we can implement today. Container queries work very much like media queries in terms of their syntax. However, instead of checking the dimensions of the browser window, they're going to check the dimensions of a specific element on the page. So this can be done in two ways, either by defining specific elements as named containers and then writing container queries for that element, or by defining unnamed containers, in which case the nearest kind of ancestor container is what will be used. So here's how that looks in practice. In both situations, you're going to need to designate which element you want to set as the container. So I think here we're setting our about class as the container, and then the styles inside the container query will be applied when the container matches those conditions. So again, kind of working in the same way that we're familiar with media queries working. We set a container by specifying container type on the element. And a container type can be set to one of two options. And I can hear you already saying, but wait, there are 3 things on the screen. Indeed, there are, but only 2 of them are really currently functional, and that's size and inline size. Size will check the inline and block dimensions of the container, while inline size is only going to check your inline dimensions. That third option, normal, which, man, we are so bad at naming things, aren't we? But that's laying the groundwork for the support of style queries in CSS, which is going to be a new query that will check elements based on applied styles and not necessarily dimensions. But they're not fully supported, and they're probably a ways off, so you don't worry about it yet. Named container queries are great for when we want to have lots of container queries on a single page, because it helps keep our code more organized and more readable. To add a name to a container, we define it with container name along with container type. And in fact, if you want to be super efficient, you can do both at the same time using that shorthand syntax. Then to call a named container, we just add the name between the kind of @ container and the conditions there in the query. Along with this new technique, we got some cool new units that we can use with it. So there are 6 new CSS units that will be used alongside container queries, all defining sizes relative to the dimensions of the container. So the example there, kind of shown at the bottom, shows a way to build kind of a fluid, flexible typography system using Clamp. And we'll get back to that in just a minute if you're not familiar with Clamp yet. But this allows you to set kind of minimum and maximum font values along with a default value, so your type can scale in kind of both directions. Then, did you know that there is a CSS property specifically designed to handle aspect ratios? This is especially handy if you're dealing with video, or like those big header images that we like to kind of put at the top of websites, where keeping that correct dimension is really important. There's a fantastic deep dive on this on CSS Tricks, but in general, this is a property that's pretty easy to apply, because all you really need is this one line. If you set a specific width value along with aspect ratio, then it will use that as a basis and automatically generate the height in order to match, or kind of vice versa. However, it's worth keeping in mind that if you declare both a width and a height, it will honor those things over the aspect ratio, so you need to be careful. Although min and max width height and width properties can often be replaced in many use cases with clamp, which again, we'll look at soon. These are still valid CSS, and they're good things to kind of have in your pocket. They're also really easy to use because they do exactly what they say, right? They let you set a minimum and a maximum width, kind of setting some boundaries there. So here in this example, we have an image. We're telling first and foremost, take up as much space as possible, 100%, right? Up until that max width, which sets a guardrail on it. So it can only get as big as the max width we're setting, and we've kind of on the smaller side said, but not smaller than 200 pixels. This is good. Don't take up more than half of the page. Also, don't be smaller than a postage stamp. Math functions are, again, a somewhat newer addition to CSS, and they are incredibly powerful. They fill a void that CSS developers have complained about for ages, which is the ability to compute values within style sheets and set ranges for properties. The sooner you can master them and start to put them to work in your applications, the more you will benefit. So these are going to be some of your most powerful tools when it comes to being able to delete those media queries. Clamp allows us to set a base value for a property, along with upper and lower caps to contain it as it adjusts. So it's kind of like if we mashed together the last thing we were looking at with the default min and max widths. Clamp allows us to kind of do all of that together in one line. So this is an updated version, again, of our last example, image with the min and max widths. Only here we're doing it in that single line using clamp. So you set your minimum value, you set your base value, and then you set your maximum value on the far end. So again, here, tell the image to take up 100% of the space, never exceed the maximum of half of the container size, never get smaller than 200 pixels. If you have ever looked at CSS and wished that it had more math, then first off, I don't know that we can be friends, but calc is probably for you. Calc allows us to do simple arithmetic with CSS units directly in the style sheet. And this is especially great for when you want to base something off of a unit that's not absolute, which, as you can imagine, is something that we want to do quite a bit when we're creating fluid, responsive layouts. You can also use CSS variables in these computations for extra flexibility. So let's say we want to create columns that are evenly divided based on the current width of the browser. Historically, setting 1/3 widths has been kind of a pain in the ass, right, when we're using percentage units, because you end up with that whole like 0.333 repeating kind of situation. So previously, our best bet was to just say, close enough, and not sweat the fact that it wasn't exact. But now we can just say, you know what, you handle it, CSS, and know that we're going to get absolute mathematic perfection from this. So we're taking the whole window value here, we're dividing it by 3, and we're setting that as the width property of this child element. If you are a fan of having your style sheets handle as many decisions for you as possible, then please allow me to introduce you to min and max. They work very similarly to clamp, but rather than setting a range that moves in both directions, bigger and smaller, it's just going to allow you to set for one at a time. So we can set the smallest or largest value depending on how the math works out. Again, super useful for handling non-fixed values, which you have to do a lot. So in this case, we're setting the widths for 2 different images. One we want to keep small, one we want to be larger. Min is going to evaluate whether 200 pixels is greater or lesser than 30% of the current container, and choose whichever value is the smallest, where max is going to make the same comparison between 50 VH and 800 pixels, but automatically go with the larger. Now, it's all well and good to think about these things from a bird's eye view, the way that we need to when we're laying out the elements on our page, but we also can't forget about the little guys, right? The units that are specifying the sizes for all these various properties we're using. And when we set everything in hard units, absolute units like pixels, we're really setting ourselves up for a bad time. Absolute values and responsiveness are very rarely going to mix. And in fact, if you find yourself setting lots of absolute values, you should take that as like a bit of a red flag and reevaluate exactly why it feels you need to set something so absolutely. Every now and again, it can be necessary, but those times should really be the exception and not the rule, because it really does make our lives a lot harder. When we set absolute values, it means we have to go back in and adjust them manually every time we need to resize the element. And if we ever want to go back and make a change to that in the future, we have to go find all of those absolute values, update them again. But when we work in responsive units, we can let them do the work for us, which I strongly prefer because I'm a very lazy developer. Two of my favorite and most used responsive CSS units are VH and VW, viewport width, viewport height. And although there's no percentage sign, that's really what these are. It's a percentage-based measurement, where one VW is 1% of the viewport width. So thankfully, gone are the days where viewport measurements had to be obtained via like window.innerWidth or inner length. Again, dark times. We were stuck getting those values before in JavaScript and then trying to find a way to tie that into our styles, which were, of course, living somewhere else. So you ended up kind of writing CSS in your JavaScript, which is one more thing to keep track of and not what we want. So thankfully, we can get these values automatically in our style sheets now and just skip all of that mess. VH and VW will also automatically resize as the user changes their browser size. So if they were to shrink the browser window a little bit, that will update on its own. And if you've set, again, percentage-based divisions within that, all of that's going to update as well. So to create a container element that is always the exact height and width of the user's current browser, all you really need is height 100 VH, width 100 VW. Vmin and Vmax are interesting little units that are often overlooked, and maybe even something you weren't aware of before. They're kind of like a child of the min and max functions combined with the VH and VW units. So they take the VH, VW measurements for the viewport and then return whichever one is smaller or larger, depending on whether you're using Vmin or Vmax. So for example, you're writing code, you set something to be 100 Vmin, you're going to get something like 400 pixels on a phone, because phones are taller than they are wide, something like 1600 pixels on a laptop. And while this might seem like something of an edge case, these are actually really good tools for replacing media queries, specifically the orientation media queries that will adjust your layout between portrait and landscape layouts. Since, like VH and VW, these are going to automatically update when the screen size or the orientation of the device is changed. So really handy for things like headers, big images where you want them to feel proportionate no matter where they're viewed. This really helps you do so without necessarily having to define all those same min and max guide rails as we might have had to do before. The addition of the viewport units was pretty revolutionary and pretty well received. They're very handy, but developers soon found that there was a bump in the road, and that was the browser interface itself. So for example, when we needed to pull up the keyboard on a mobile phone, that changes the height, right, the VH of our window. And sometimes VW was thrown off by something like a scroll bar. Again, that might come or go depending on how the interface of the browser itself works. Sometimes on a phone, right, you get the browser address bar that goes away as you scroll. That also changes the VH. And this all led to some requests for adjustment. And we got that in the form of 12 new CSS units related to the viewport. So basically, the large viewport units here apply to the situation in which the browser or operating system UI is not visible on your page. So totally full screen, you've loaded a page on your phone, you've scrolled down, the address bar is no longer visible. So you're not getting the Chrome, the forward and back buttons, you're not getting the refresh button, all of that. It's entirely page content. LVH, LVW, LVmin, LVmax are all sized assuming the largest possible viewport situation. The small viewports are the opposite, right? This is the size of the browser when all of that crap is visible. So SVH, SVW, SVmin, SVmax are telling you the smallest dimensions that you're getting back when a user has all of that stuff available on top of or around your site. The dynamic units are where the real magic happens, though, because that's kind of the clamp of viewport units. It's going to automatically adjust in response to whether those UI units or elements are visible or not, so you get this kind of middle ground. It's like a Goldilocks situation, you know? So you could set a DVH of 100% on your body. That's going to create pages that will automatically adjust themselves to fit the available viewport, you know, whether the keyword is up or not, which is pretty darn cool. If you don't necessarily want to base your sizes on the viewport, you can try on rem and em units for size. The name em actually comes from old typographic standards of measurements, which are based around the width of the actual letter M in the font, which, by the way, is also where M dash and N dash come from. Dash is equal to the width of the M or N characters. So next time you are playing bar trivia, you're welcome. M units are a way of defining your font sizes relative to the font size of the parent element. So you could do something like H2, font size 2.5 M. That sets your H2 headers to 2.5 times the size of the current body font in the parent element. Rem, on the other hand, is allowing you to declare your font size relative to the root font size of the entire page. That's what the R stands for, is root. Both rem and em are working in the same general way. It's just dependent on what they're using as their base, what they're scaling based upon. In general, I lean towards rem over em most of the time because I find it a little bit more consistent. But one of the most common questions I get is, okay, so when do I use em? And the answer to that, I think, is if you're looking to create a specific design in one area that's going to be different from the rest of the overall style. So maybe you have a call-out box, maybe you have a sidebar. You want that to have a different style system than the rest of the main page. Em is going to want to be what you reach for there, so you can create consistency within that single element. And if you're looking for a cool trick, again here, you can combine VW with rem and clamp, create a fluid typography system that's going to apply to your entire application with just this single line of code. Here we're setting the base font size, 2.5 VW, so again, remembering 1 VW is 1% of the viewport width, and then we're setting our min and max values on either side to ensure that we don't end up in a situation where the text either becomes too small to read or too large. If we're using relative units for the rest of our typography, we can then base them on this fluid value and allow those to all flex and adapt naturally as well. So, done and done. Here we have another couple of weird ones, which again might be more fun for trivia, but they are responsive and they are valid, so I'm going to tell you about them anyway. At the very least, now you can impress your team with your knowledge of obscure CSS trivia. I'm talking here about CH and EX, which are both measurements based on the size of an individual character. They're going to work in the same way as rem and em in that they set sizes based relatively to a font in use on the page. X is a unit that is equal to the X height, or basically the midline height, of the first available font, meaning the first one listed in your font stack as defined in your font family's property or whatever default font you have going on. So the midline of the font is always going to be kind of the medium, and that happens to be the same size as your lowercase v's, your lowercase w's, and of course, lowercase x's. So when we use the X unit, we're defining something relative to the height of the lowercase x in the currently used font. Is there a practical use for this? I have only seen one. That is actually superscript and subscript elements. Because both sub and sup are notorious for screwing up your line height. You know, if you add a superscript, it's going to create a bigger gap between that line and the others. And if you're using those elements, which you should, for accessibility purposes, be using sub and sup, then you'll have to go in and manually adjust that line height so you don't get the awkward gap. X is weirdly perfect for this because we do want that line height measurement relative to the height of the font we're using, so that's the example shown here. We're positioning the superscript element and setting kind of the bottom of that based on the X height. CH is similar, but instead measures character width. But wait, you said rem and em units just do that. What is the difference? Why is this happening? I don't know. The answer is there's almost no difference. The only difference is that CH is calculated specifically based on the width of the 0 character. What do we use that for? Again, I'll be the first to admit, you're probably not going to pull this out in your day-to-day. There are a couple use cases, though, where it's handy. Some folks argue it can be a good way to set the max width for text blocks or text inputs, because we do have data that tells us the human eye most comfortably reads text that's between 60 and 100 characters in length, including spaces. Shorter than that, we get too many line breaks. We have to kind of break a thought too often. We have a hard time tracking it. Longer than that, we lose our place when we get to the end of a line and have to come all the way back to the kind of beginning of the paragraph. So 60 to 100 characters is the sweet spot. So you could make an argument for using the CH value, perhaps on either side of a clamp, to ensure that as your page is resizing, text blocks are always staying in that kind of ideal legible window. But personally, the use case I've found for this has to do with numeric displays, because a 0 is usually the widest number in a font of their numerical thing. So using CH to define your layout ensures you're not going to end up in an overflow situation for a numerical input, even if someone has to put in all zeros. Last but certainly not least, you probably already know about the humble percentage unit, but if you're going to be setting widths by hand for any reason, as opposed to using something like grid or flex, then you're almost always going to want to reach for the percentage instead of any kind of absolute measurement. So again, probably didn't need an example here, but I couldn't bear to leave one single slide without an example, so you get one. Here's a container. It's set to 1/4 the width of its parent. It's revolutionary. Now, when we are talking only about responsive design, it's pretty safe to say that with all of the stuff we just covered, you can say goodbye to your media queries. You can replace them with some of these newer approaches. But there are still some situations that are not related to responsiveness, where media queries are still our best option. So before we throw them out entirely, lose the baby with the bathwater, all that, let's talk through a few examples where our old friend at media is still going to be the thing that we want. When it comes to ensuring that your app or your site is accessible, media queries still do play an important role, and when that happens in relation to the prefers features. So the most widely used of these are prefers reduced motion and prefers color scheme, although there are a couple others that we know are in the coming soon phase, kind of still gaining popularity, still getting worked out. We know things like prefers reduced transparency and prefers contrast are coming. But with user preference media features, we can adjust our content kind of preemptively based on the user's system level settings, and that allows our layouts to be more accessible and user-friendly because they don't require the user to load and navigate an inaccessible page in order to then go change their settings, right? So if a user has already enabled dark mode at a system level and we're using prefers color scheme, they don't have to load our application in light mode and then go change the theme, right? It can feel a little bit more intuitive, a little bit more automatic. It's a small but really nice thing that we can do to improve that experience in our applications. Next, if we need to change how an element on the page looks or works, or if we just want to remove it entirely under certain situations, there's still not really a better tool than media queries and breakpoint-based changes. So really common example here is the switch from a list navigation menu to a hamburger icon between a larger and a smaller screen. When we really need to do that display none swap, media queries are still our best option here. Now, if you have never had to worry about styling something on your website or in your application for print, let me be the first to say, congratulations, and I am deeply jealous, because this is an annoying and difficult task to take something that was intended for responsive viewing and make it work on a whatever standard size piece of paper. But when we do have to do it, media queries are there for us. By specifying print, we can set a whole new set of styles that are only going to be applied to our layout in the print format, right? It's not exactly cutting edge, this is not new technology, but if you're working in an application where you know your users are going to print something like maybe a report or a chart, some kinds of data visualizations, this is really handy because not only can we get everything sized appropriately, we can also hide things like the navigation bar that are just no use to us when they're printed out, right? Can't click on it, might as well ditch it. If you are still relying primarily on media queries to ensure that your app or site is fully responsive, then it might just be time to take a look at all the new stuff CSS has to offer and see if maybe you can swap out some of those old-fashioned breakpoints and try on one of these new fluid approaches to styling. Working to create a fully fluid layout means less drastic changes for your user when they're moving between mobile and desktop or even just resizing their browser. And it also means less maintenance work for you. No more updating every single breakpoint every time there's a design change. Leverage these adaptive approaches to styling and get ready to sit back and go with the flow. So Here's to making more great stuff for our users and making our own lives easier. Thank you guys so much.